Good afternoon. I'm Nick Kalyani. I'm the founder and CEO of Decentology, and joining me today is Morgan Weil. And today we are going to talk about composing the Hyperverse. So before we go there, let's start where we are or where we were with Web 2. So in Web 2, success has largely been driven by APIs. Developers can easily use APIs to build applications, and that's been great. There's great examples of them. If you want to do checkout, you use Stripe. If you want to do messaging, you use Twilio. You use AWS for storage, Google Maps for location. So there's all of these convenient APIs that are available. So what this did is it made Web 2 really open for developers. And that's why you see this explosive growth of apps. The one thing that APIs do also is they don't compromise security. Like with OAuth and technologies like that, it becomes really simple for developers to access APIs in a secure way. But in doing all this, what it did unlock is opportunity for millions of developers around the world, where it doesn't require more than just a simple basic computer and a pipe to the internet. And you can build things easily because all the tools are available for free. And that is opportunity. So because this made application development so easy, we saw this rapid growth. And the way people use APIs for building apps, this is the power of composability. And that is the reason Web 2 has been so successful. Now, let's take a look at Web 3. What do we have? Well, for developers, Web 3 is extreme friction. It's high friction. The smart contracts development requires advanced skills, which are in very short supply. It's really hard to find smart contract developers. Code libraries are often broken. And this is probably due to the fact that things are innovating so fast, things are changing so fast that there's really not enough time for people to keep things in sync. Also, developers start working on larger contracts now, and these large monolithic smart contracts tend to become insecure. It's a larger surface area, right? So you're gonna have more code and therefore more opportunities for bugs. There's no solution for smart contract discoverability. If I create a smart contract and I deploy it, I get an address, there's no way you can find it. You can't go Google it and find my contract unless it becomes super popular and then other people are sharing it. And even then you have to be wary that you're not getting some wrong scam contract or something like that. So discoverability is a huge problem. And what this has caused, all of this has together caused a problem of adoption. So why is Web 3 developer adoption very low? Well, it's all of these things combined. And what we wanted to do at Decentology is think about a solution. So what did we come up with? Well, we felt that the number of smart contract developers with advanced skills, what if we could leverage those and make it easier for those without all those advanced skills? So what we came up with is an idea that is already existing in Web 2. We wanted to create smart contract code that is very modular. You can even think of it as blockchain primitives. Do one thing really well. So that's the basic concept. And within those modules, we also thought what would be cool is if there was built-in discoverability through metadata, both on-chain and off-chain. So someone could go and search and say that, hey, I want to create a specific type of NFT, and boom, you see all the modules that are available for it. So one of the challenges with any kind of code, not just open source code, but especially code that is open source on the blockchain, is how do you trust it? Well, we came up with the model of community auditors, where auditors could audit that code, and if they felt that code was trustable, they could stake their tokens as a sign of confidence. This acts as an insurance layer for open source code. And then in aggregate, what we wanted to do was essentially bring to Web 3 the concept of APIs. So that's basically what we've been working on. And what we call these modules are smart modules. So you have smart contracts and we have smart modules. So how does this come together? Well, essentially, you can think of smart modules as smart contract building blocks, as Legos. As developers, what we wanted to do was make it possible for other developers to simply wire up different blocks in an intelligent manner and have an app. So really don't go through the hard cycle of figuring out how to write the whole contract from scratch. Just pick things that other developers who are very experienced and proficient and that has been audited, like you put those blocks together and build an app. So what this does is it allows you to build decentralized apps that are very complex. However, the development process is super simple. And that's kind of what we are shooting for, because our mission is to onboard the first 10 million Web 2 developers to Web 3. We are not going to get there unless it's very, very simple. So the resulting applications, if you look at the model and the fact that it's been audited, the applications are going to be more secure than if you were to write the whole contract yourself. And this now is unleashing the power of composability in Web 3. So it worked on Web 2. Let's make it work on Web 3. We call this the Hyperverse. And it's an open, DAO-managed, decentralized marketplace for composable smart contracts. And it's blockchain agnostic. So our company is transitioning to a DAO right now because we feel that a model like this is only going to be work if it is community owned and community managed. So that's what the Hyperverse is about. So quick rundown on how it works. So basically, as I alluded earlier, experienced developers, they can build these smart modules. Then we have in the community registrars who will validate packages. The package might have a manifest, it might have metadata, etc. They validate that. And then auditors, they verify the code and they stake tokens. And that becomes your smart chain module that goes on chain. And it's then available to everybody and it is discoverable. Now, here's how this experience works for web developers. So this is for the smart contract developers, which we assume will be a smaller number. For the web developers, all they do is use common HTML, JavaScript, and CSS. That's it. They don't need to understand anything about smart contract code. And it's really that easy for them. And today, I'm very pleased to announce that right here, right now, we are launching our Algorand preview on the Hyperverse. And to show you that live is Morgan Weil.
Thank you, everyone. First of all, I want to express my thanks from myself and the company. The Algorand community has been very welcoming, and from Discord to online forums, it's been a pleasure. We're just fresh citizens to the community. We want to be good ones at that. So yeah, thanks for being great. So as Nick said, the simplicity is a key component, and we want to introduce people into Web3 with things that they know and are familiar with. So I'm going to start with something that's pretty popular. So our only thing that is required to take part in our stack right now is React 16.8 and above. We're using React hooks as the primary interface method for these components. And since we have a computer hooked up, I might be able to do a tiny demo here. All right, so what we start with is we import the Hyperverse and a Hyperverse counter, which is a module, a smart module. So that combines Algorand smart contract code with JavaScript interfaces and hooks so that the Web 2 developer is able to interact with it without actually having to send any Algo SDK transactions or understand any teal or PyTeal stuff. So we then initialize it with a Hyperverse promise. We set two things, well, three things really. The blockchain, which is in this case Algorand, the testnet for the network that we want to work with, and we describe the modules, which is the dependency array of everything that we depend on for the developer. And in this case, it's only the Hyperverse counter. The tenant ID is something that will become relevant after we launch out of preview sometime in January. So that's the Hyperverse premise. You initialize your Algorand testnet modules. And then a pretty familiar pattern, you initialize your Hyperverse provider with the Hyperverse premise. If anyone's written any kind of Stripe code, you'll be familiar with this pattern using the context and the provider. So what does this do? So inside of app, anything that's being composed inside of app gains access to the Algorand part of the Hyperverse. And I guess everyone wants to, when they go on a decentralized app, they want to log in first. Like the experience starts when you log in and you authenticate. So how do we do that? Well, with what we have in these hooks, we use Algorand, get access to the Algorand instance, and check for a method, which we call on click, whether the Algorand account is connected or not. And if it's not connected, we connect. And if it's connected, we allow for disconnect. And how does this look exactly on the website? So this is streaming live from my phone. algorand.dev is available for you guys to check out after the presentation. So there's a connect button down at the bottom, and if I can bring up the source code side by side. So this connect button, once I tap it, you'll see a familiar Algorand wallet integration. It's being used inside of the hook. We click on Algorand wallet, and we should get a prompt if the internet's working. We connect, we go back to our app, and then we're authenticated. There's down at the bottom, a link to the testnet we can explore. For decentralized developers, the time to testnet explorers or any kind of explorers is very critical. They want to see their stuff online as fast as possible. And we achieve that literally with one click. So that's the authentication part. And it's as simple as calling a couple of methods and checking against a parameter. So what can you do when you log in? Well, the baseline stuff, we're trying to enable anything you could do with like an Algorand wallet, but inside of a React interface. So we've enabled transfers. And how do you transfer stuff using our Hyperverse Algorand hook? So again, we use Algorand to gain access to the instance. And when we click on transfer, we call a method on the Algorand hook, transfer algo. We set the recipient and the amount of algos that we want to send. And that's it. It's a pretty simple integration. The button that's responsible for this is down here. And on click, we just hit up on transfer. And now we've enabled Web2 developers to send algo back and forth. Again, let me bring up the demo. So how does this look in person? So let's bring up Playground, transfers. There you go. So this is the same screen that you saw right there. And I'm going to try and send, this is my own account, so the transfer is going to be weird. But after I click transfer, the signature modal appears. And again, this is something that developers oftentimes they need to implement this themselves, and it's kind of painful to hook into the entire pipeline of signing and waiting for that to be included into the block. With our hooks, that comes included into the context provider. So we sign, open up the wallet again, and we get a pop-up, confirm it, accept it. And if we go back, we get a transactions list with all the pending transactions listed in there. So this interactive part continues, we were able to click on the account. Now we're able to inspect our transactions in that list. So it went from pending to completed. And if we click on it, we're sent to the Algo Explorer to see the details right there. So again, time to things happening on the blockchain is very critical, and we get there in a couple of minutes. These widgets are sort of optional parts of what we're doing. We're trying to help people to get as fast as possible to transacting. The core parts of it, the hooks and interacting with Algorand and the Hyperverse are not optional, but the UI elements completely interchangeable. Just there to help people out, get started faster. All right, so that's regular algo transfers. We have smart modules. We spoke about the whole concept of a smart module. So a smart module is not only a smart contract that has a bunch of logic, and I know there's a ton of AVM improvements coming up. If any of you attended the session yesterday, 1.0 will include contract-to-contract calls, and that's very important for what we're doing with the Hyperverse, just enabling you to interact with other contracts. So, thus the preview part of it. We're not ready for the full launch just yet. But we do have sort of an example implementation of a smart module that does not depend on any other smart contracts. It's the counter smart module. You've probably seen this example in the Algorand documentation. The contract itself does a simple thing. It holds the value in global storage and allows the user to increment or decrement that value. Now the source code we can see that we're not only using the Algorand hook, which we include from the Hyperverse, but we're also using the counter hook, which is the primary way that we will interact with these smart modules, specifically the smart module APIs and interfaces that have been exposed by the developer. So this specific smart module inside of its JavaScript export has 3 methods. There's one for fetching the current value, there's one for adding, and one for deducting the value. So how do we integrate that into our React app? So I'll get back to the live feed right here. I'm gonna put up the counter. So what do we see on screen here? We see the current value of the counter. Now, anyone is free to go to algorand.dev/playground/counter and add or deduct. The counter is sort of a global state, so it's not tied to the specific account. Now, this logic would require all kinds of Algo SDK interactions with setting up transactions, making sure the contract does what it needs to do. But what if I'm just a Web 2 developer? I don't know nothing about Teal or PyTeal. I just want to have this counter and allow my folks that can log in with their Algorand wallets to play around with the system. I use the counter hook, which I've declared as a dependency inside of my app.jsx. And then let's say I want to fetch the latest value. I click on update count, and that's calling line 14 right there. This little tiny function, and it just resets the count using .fetch count from the counter. I can also update my stuff using the add and deduct functions. So those are transactions, they need to be signed, and that's a messy procedure. And if it's something so simple as an add deduct, we wouldn't spend this if we had to do it all by ourselves, but having a module kind of simplifies that. So I tap on add. I'm brought up with this familiar transaction signature modal, and I can sign it, and I'm taken directly to my Algorand wallet. Confirm the transaction, accept the disclaimer. And when I'm back, I see another transaction pop up in that list, and I can sort of inspect it, look at it while it's pending, and it's completed. So the counter updated to 22, which is what we would expect if we click on add. Now, just to prove that the system does work, and let me tap on deduct, head back to Algorand wallet. Now, I want you to pay attention that I'm not really sort of losing on the user experience. This is me interacting with the wallet. I'm not signing in through any Google account, auth provider, or anything like that. This is native Algorand. I'm, Web3 native experience. And this is something that we believe in as an industry. We should be going towards decentralizing, decoupling from the identity providers, and just sticking with the wallet, sticking with the identity that's provided by the Algorand accounts. So we added, we deducted, and in the source code you can see literally I'm calling those 3 exported methods directly. So on click for the add button, we have counter.add and deduct counter.deduct. Now the automatic updating of the counter, that involves the Hyperverse Algorand hook. And there's this thing we call pending transactions. It's an array, but there's also a Boolean flag that's flagged if there are any pending transactions. And if there are, it's a good indicator that something's happening. And at the time when it flips from true to false, it's a good moment to update our user interface. So it's something simplifying a complex interaction. And in this case, we call update count whenever Algorand.has pending transactions is false. So that's the counter smart module and how to integrate that inside of React. Now, as a Web 2 developer, and my background is full stack and mostly React, this is familiar. I can understand this, and I don't need to go through pains to get to this point and start using it. I went through a lot of pain trying to understand Algorand and understand PyTeal and understand the Algo SDK and how transactions work, and that there's different transactions for every single thing you want to do. And that's not something we should expect Web 2 developers to do. It's a big ask, and we shouldn't be making that ask for the industry. Thus our motivation to start working on simplifying that. So it's not only the marketplace that we're working on, which is great. And I mean, it will allow really good smart contract developers to get their stuff out there. But there won't be that many really good smart contract developers. There's a lot of money involved. There's a lot of risk, and people need to take their time. So we can't expect everyone to be a smart contract developer. However, we should expect the tens of millions of web developers to jump onto Web3, because this wave is coming, and they're going to get there somehow, and we want to help them get there. Now, how do we help them do that? So obviously it's the interface, it's the React hooks, it's talking to them in their language, in their environment. On top of that, this thing that I've been showing is the UX that we're trying to build for a playground experience, which is a GUI, a graphical user interface, for interacting with each and every smart module. So a smart module, sure, it has the smart contract code and all the auditing and all of that comes with on-chain stuff. But on top of that, and just as critical for it to bring on users, is the playground experience. So like, I'm looking at this website and I'm playing around with this smart module. I'm adding, deducting, updating my account and whatnot. And I can see all the live changes happening. So every smart module that's going to be on Hyperverse is going to be required to have this experience for people to try it out with a GUI, no code, no nothing. And if they like what they see, they can start integrating it with the hooks that are provided by the smart module. And this is just a taste of it. I do want to stress that we're still waiting on some changes that will be introduced with the 1.0 release of AVM. But for now, anyone here can try algorand.dev to see everything that I demoed on stage. There's the counter example, there's transfers, there's even a tiny ASA example of a fungible token. So that's where you should go if you want to check this out. Now, if you want to learn more about what we're doing with the Hyperverse and the progress we've been making and will be making in the coming future, go to Decentology.com. There's going to be a section on the Hyperverse, and anyone that's a smart contract developer, we really want to collaborate with you. We want to see what you're trying to build and how to integrate that with the vision that we have for onboarding the next 10 million Web 2 developers onto Web 3. So please reach out. And with that, thank you for your attention, and I'm out.